watching NotesIn9.
Hello, and welcome to NotesIn9. I'm David Leedy. Episode 192, Intro to Graph Databases and XPages. It's all about relationships. Okay, in this show, Oliver Busse comes back on. I am so excited about this. First, he's at Twitter at ZeroMancer1972. He's on the web, of course. He's a big influence behind OpenNTF, a member director, and he's got a bunch of projects out there for you to check out. He's an IBM champion. He's done a ton with XPages and Bootstrap. He works for the great company We4IT and is working on the very interesting Avito application framework. And he also does music. And on top of all that, every now and then he stops by NotesIn9 and just drops a bomb of goodness on us. So I thank him for coming back. Now, I actually did get this video quite some time ago, and quite honestly, it's been a very hectic last couple months for me, and it's taken me way too long to get it out. So I do apologize for him for that. But it's a great video, and it is worth waiting for. And what he's going to talk about today is graph database. And you may not know what that is. It has nothing to do with graphs, like bar graphs and line graphs and pie graphs or so. It's some kind of a database theory or technology, I guess it's more than a theory, that is specific for relations between different types of entities or so. So this is what the big boys are using. You see like the Facebook, who your friends are and stuff like that, and LinkedIn and Amazon, how they, try to find different products you're interested in and things like that. So this is kind of, and Twitter, of course, it is a big graph database user, it appears. So this is kind of like what we're talking about here, and what you can do through the magic of the OpenNTF Domino API and the hard work of many members of that team. Nathan Freeman, I know, has done a lot with this. Jesse and Oliver, I believe, have. Though I think Nathan is the driving force of it. And if I forgot a name, I do apologize. But they interjected into the API as an optional. You don't have to use this, but the ability to do graph databases, storing that information inside a Domino NSF database. So it opens up this very interesting world of possibilities for you, the XPages programmer, where you don't have to have a view for every little thing, and which, those can be performance nightmares or so. So this graph technology is extremely fast, from what I understand, and very flexible. But I'm not really the guy to talk about that because I watched this video and I'm like, oh, wow, it looks like magic. So I'll let Oliver explain it to you, and he does a great demo on how to on what it is, what it kind of looks like, the before you use a graph database and after you use a graph database, and kind of how you pull it off. And with all that being said, let's go to the demo. And here is Oliver Busse.
Hello, good morning, good afternoon, and good evening. My name is Oliver Busse, and I want to show you some cool stuff today. And it is about using the GraphDB capabilities from the OpenNTF Domino API. Actually, I did some sessions about it at ICSUG conference and at Entwickler Camp this year. So I actually can start with some basic slides to introduce you to what is a GraphDB and how to use it in your XPages. So this is me. If you want to contact me, have any questions about it, what you will see in the next few minutes, don't hesitate to tweet me, to mail me, or whatever. And for the most important part, what I'm talking about, or what I want to talk about, is what is a GraphDB. So in this picture, you can see the basic principle of a graph database. A graph database is containing what we would call objects or elements, or maybe in terms of nodes and domino, documents. And these objects are on this chart, those bubbles, those circles, like Julie, Steve, and Bob. are objects, or let them call them elements. So Steve is an element type of person, Julie also, Bob also. BMW is an element type of car manufacturer. Rock music is, yeah, music, of course. And IBM is on the chart too. And of course, he is an employer. So what you can see, there are objects, and I hope you can see the arrows that point to one object to from one object to another, um, and they having a direction. And this is what the GraphDB is all about. It's not about mainly storing informations about objects or elements with those with its properties, key values. But it is about storing relations from one object to another. So basically, we want to find a way to store relations from one object to another object. This is what the GraphDB is all about, and in the next few minutes, I will show you how to provide that with a with a simple domino XPages based applications. Okay, next slide. This is a basic definition of what a GraphDB is all about. It is stolen from the internet, as you can see. There are tons of definitions out there how to describe a graph database and the principle behind it. So it's basically based on a non-SQL database. As we have with Notes and Domino, it's also no NoSQL database. And it is storing relationships, as I said already, and it also contains data which is defined as so-called nodes and edges, but I will tell you in a few minutes. So if we are talking about using GraphDB capabilities on a Domino environment, of course we want to, or we have to use a special framework for it. Here are some other frameworks on this slide mentioned you may have heard of before. The most famous is, of course, Neo4j, which is a pure Java-based GraphDB framework, including database access and data modeling and so on. It's a very complex one, but it's a very old one, which doesn't mean that it isn't good, but it is an old one. It's still under development, so you can use it. And I think it's the most common framework that is used out there. OrientDB is not a framework, but is a database, of course. And there are some other frameworks and databases mentioned here on this slide. One of them is the famous Apache Lucene/Solr, which is often mentioned when it comes to IBM Verse and the search engine they created for IBM Verse to search within your emails and calendar entries and so on. They are using Solr on the cloud-based IBM Verse instance. So what I'm talking about today is it's not so far away from our daily work. So if you're using IBM Verse, you are already using GraphDB. So now I want to show you how to use that in your well-known applications, in your legacy applications or in your XPages applications. By the way, by legacy, I mean, of course, not Notes client-based applications. Of course, I mean XPages ones. But I don't mean to that you have to modify your legacy data in your old applications. Because what I'm trying to do is to put something on top of existing infrastructure and give you more functionalities, more values to your existing data. So when we are talking about implementing GraphDB functionalities to XPages apps or to your Domino environment, we are always talking about, or mostly, we are talking about adding functionalities to existing data. Okay, the last one mentioned on the slide is Tinkerpop, and yeah, this is the framework that is used in the next couple of minutes because it is part of the OpenNTF Domino API that I'm going to use. So to get you another idea of what is a GraphDB, I put some famous names on that slide that only want to show you who is using GraphDBs. Of course, Amazon is using it. If you click on a product, you will see, okay, that part on that product page which says customers who bought this product also bought other products like these. So this is a connection. This is a relation to products, to other products I might be interested in. Google, of course, is indexing the websites and those topics and movies and images and whatever. Facebook, the classic one, using GraphDB. If you like something that a friend of you posted, then you are creating a relation because you are liking an post from a friend or from whoever. And even the friendship is a relation. And I think this is the most common description of how a relation works. A friendship is a relation. So there are some terms that we have to get familiar with when we are working with graphs, and if we want to search on the internet or if we want to ask questions in the forums or in the Slack channel or wherever. So GraphDB comes with this terminology, and as I said, we are talking about objects, elements, something like that. But those guys are often referenced as vertices or sometimes nodes with a D. Not our nodes, but nodes. So the most common term is vertices, and the singular is vertex. A vertex contains properties, and properties are, as you know, key value pairs. Relations between two vertices are described through so-called edges. Those arrows from the first slide, from the chart, are called edges. These describe connections and relations between vertices. A secondary term, secondary because it's not related to the data itself, but of course it is related to all the data in general, is the so-called element store. It's nothing else than a database. In this case, in our case, for us Domino developers, it's nothing else than an NSF database. And there's another term that was, I'm not sure if it was invented by the ODA programmers, especially Nathan Freeman, who put this idea into the OpenNTF Domino API. One day, it's the so-called metaverse IDs. A metaverse ID is a combination of a replica ID and a unit, and it is only used for internal usage when it comes to the implementation within the ODA. You don't have to care about them. So let's say it's just some kind of coordinate to find your data, because you will see it. The data is stored loosely in that element store or in the element stores if you are using more than one. But the most important part is we don't care about them. We don't have to care about them because the implementation will do the work for us. So the terminology that I just showed you regarding the Domino way we want to use them is vertices and edges. Of course, has to be stored in our NSFs as nodes documents. And as I said, the data container is an NSF. It's one or more nodes database. We don't have to create them. the element stores will be created automatically if they don't exist. So this is one benefit for us. What we have to do is to define where to create those NSF files, but this is the only thing we have to do. And you can use different element stores, but you can only use one element store to hold different types of vertices, but you usually want to create element stores for each vertex type. Because imagine if you are dealing with a lot of data, then it might be a better practice to separate them in different NSF files. An NSF file can hold millions of notes documents. I think most of you think that that millions is a way too high amount of documents, but Notes can handle that, and Domino can handle that. But it depends on how big the documents are, and if there is a lot of text in the fields or rich text or whatever. If there is only a small amount of information per document, then you are able to create millions and hold millions of documents in your NSF. One caveat and one bottleneck might be a view that you want to open in the Notes client or even on the Domino server when it comes to searching, because of the index. When I say index, of course an NSF is an index-based application, an index-based database. A GraphDB naturally is not an index-based database, so it normally doesn't have an index, not an index like we are used to it. But of course, there is something like an index, but it is transformed, let's say, in a way. Let's say there are algorithms that do the work for us instead of using an index, and so it is for NSF files. It's a bit abstract, I know, but I don't really care about it, how it works. It works, and it works very fast. And if you want to have numbers about how fast it works, just ask Nathan. He did several tests with millions of documents in several element stores, and it was blazing fast. And yeah, I don't know how it works, but it works. I just want to show you how to implement. Okay. There's another benefit of using the GraphDB stuff from the ODA regarding data modeling and implementation. Let's stick to the data modeling. As a Notes developer, you are used to model your data with forms and views. So if you want to create a new field in your Notes documents that you are going to create, then just add a new field in your form, use that form to create your document data, and you are done. The data modeling part of a GraphDB-enabled application, also in this case, is without using any forms of use. It's just about coding. It's just about creating classes or not classes in this case. You are creating interfaces for each, let's say, Notes document type or data type. How this works, I will show you later, of course. You define fields with getter and setter within that interface class and some other extras. You are also defining methods in your interface that describe some not capabilities of that object, but yeah, somehow there are capabilities that you are describing with those methods. Let's say if you add a method that is called from an object of type of a person, maybe a user document. Let's say I want to get all the customers that this employee has been working for. So traditional Notes developers run through several views, loop through them to collect the data in several data stores. and save them somewhere and put them in lists or whatever to display them to the end user. In this case, this method is only has only to be defined, and the rest is done by the GraphDB itself. So if you define your objects wisely, then you are able to just call a single method and you get what you want without doing lookups and doc loops and whatever may bother you in nodes development. So this is very, very easy. Okay, methods also return all edges to a certain vertex. Yeah, this is this could be a best practice way, but you don't have to do it. Okay, before I show you code, it's just about talking the theoretic basics. Before you can work with the graph stuff in your Notes application, you have to define the element store or element stores if you want to use more than one. In my demo, I will only use one element store, a separate element store, which is not the application itself, so it's a separate database. You add those defined element stores to the so-called graph configuration. And then you define the final graph element, which is called a deframed transactional graph. With all those inputs you created before. And then you can work with it. The definition or the instantiation of the deframe transactional graph object can be done anytime. So there is no need to check if this graph is already existing or if the element stores are already existing. The implementation in the OpenNTF Domino API will check that for you, and it will only create those stuff once if it's not there, and afterwards it is just using it. So no hassle. So if you want to create an edge relation between two objects, you have to parameterize the first object, get the second one by a key. So you got to get two objects, the one that is connecting to the other. And then you just call one of the methods you predefined in your graph object before. They must start with the word add in the method name. I will show you that. And you are done. To finally store those edges or even changes within vertices, you have to call a commit method of the graph itself because it is a transactional object. It writes the data to the disks only if you call that commit. It's also different from the behavior you are used to when dealing with pure nodes data. Okay, this is a slide you are waiting for, so I will stop that. I will show you a simple application. This one. So this is an application which is an XPages application. So there's no UI, really no UI for the Notes client. But there is of course something behind it. I will open it in Domino Designer. There is some views and a form. In this case, a form called user. So just to show you how the data got there in that database, I created some documents with that form. And you can create a new user document and use that simple form. So imagine that this is an existing application, and this is what I call a legacy one. No user front end for the Notes client and just data in it. And of course there are some documents inside. So I deactivated this one. As you can see, there is a different form name. But if I open this one, you can see, there are some fields in it, and there's even rich text fields and so on. And I got several of them, completely unsorted and so on and so on. But when I open that application in my browser, it looks like that. I put an X page on top of that application, which just reads the view or reads all the users, reads the rich text content here, displays it in a nice way. some layout and so on and so on. This is nothing special regarding XPages. So I can show you that XPage. This is the index XPage I'm using. I'm using my bootstrapped template here again, and there's somewhere there's a computed field. I think I don't know where it is, where the repeater exists, where the profiles are just displayed, and they got links to their corresponding documents. So I can click on a name or a face, and it opens the profile detail page, and it shows me, yeah, all the fields that are inside that document. And there are some fields that I want to point to. On the right side, there are fields that contain lists, text lists, simple multi-value text fields here. Skills and expertises, projects and leads. I only implemented the skills and the projects yet for that demonstration. There is also a field that holds the birthday date, which is also yeah, transformed to the GraphDB. But this page simply shows the notes document and the values that are inside that field. So of course there's a repeat control inside which shows all the skills. And if I open the user document, I hope I will find it. At first, yeah, here we are. This girl is great in coughing. I hope you maybe you know the Little Britain series, which is great, and yeah, nothing else. And I just create a new value for that field, and I only created that new text entry. It's a simple text list. So if I hit refresh on that notes-based notes document profile page, you see there's a second skill added to this one. So this is a traditional way of accessing data and of course storing the data in that user profile in this case. But imagine this application should be, yeah, should be developed to a bit advanced one. So you want to put some more functionalities in. For example, if you want to search for people that have certain skills and expertises, of course you can use a full-text search. Let's see how the full-text search, how fast the full-text search was. So if I return to the start page, I can select coughing, and of course I find that profile. But as you can see, the tech cloud doesn't even contain that new skill I just added. What I have to do is to manually update that index so that the new value I just added will be added to the index. So if the index sometime is updated, it might show up here. It might. I have no idea when it will be the case. Of course, the detailed profile shows something, but yeah, of course. In this case, we were lucky that the tech cloud was buggy, but the search, the full text search, already works. Okay, this is great. So, but I can repeat that. With that profile, just to show you the disadvantage of using full text searching. I just add another value, and if I search for Fuba, I have to fake that for the search term. You can see I use the query, the right one, but the full text doesn't contain that term at this time. So again, have to wait for the full text index to be updated, and then I can repeat that search process, and then the entry shows up. Okay. Yeah, that's okay. A second one is I want to make sure that that there are no double entries or no redundant entries, or maybe entries that are similar. So I created a view here where all the skills show up, and you can see if I select a document here, you can see some other entries are selected too, because this is one single user profile which contains all the three. So this one contains just one, and this one contains all the three. And if I add the foobar skill to that profile, of course it will display two entries under that category. The problem here is that I, of course, can misspell the skill a bit, which may result in something that I am not expecting. In this case, I think the formula behind that column will transform the field value into a proper case value. Otherwise, I would have two categories with the same name but with a different spelling. So the problem is that the user is able to create data that is not useful, or that is not that useful as you want to have that data. My main aspect is here to show a different way of how to add those skills to a person profile. In my model, a profile is one type of object, or let's call it vertex. And the skill is also a type of vertex. It's a skill. So if I go back to the chart I showed you in the beginning, let's say that Julie is the profile, in this case a human being, and I want to create a relation to not a different, in this case a special music type, but to a special skill, which is which is almost the same. Of course, it's not the same, but you got the idea. I want to combine those values. I want to connect them with by creating a relation. So what I want to do is create a skill if it doesn't exist, or let's say I want to add a new vertex of type skill with a special name. In this case, maybe foobar or JavaScript or whatever. Um, and then add the connection, the relation to that profile. This is one action I have to take. So what I'm trying to do is to create an action for that in my on my XPage. But before I can do that, I have to migrate my existing data, because we are dealing with just one document type here. There's a configuration, okay, but on the other hand, we are just dealing with one document type here. It's a user document. I will manipulate that value to show myself up on the list. So I'll show you my start page again, and there's me added. This is what I wanted to avoid in the first demo. Okay, I am here again. So we have user documents. Now imagine other document types, either in the same database like this one, or in a complete other database. Maybe the skills should have been created in another database, or in my first example, I mentioned an employee is stored in a database. Of course it is, because we have names and address book where all the users are stored. And maybe customers or projects are stored in a completely separate database, which is sales regarded or human resources regarded or whatever. So you don't have to manipulate the existing data. You only put some additional data, let's call it metadata, on the top. And this is what we are doing in my example now. So we have to migrate the existing data. This is where some code comes in handy. So I have to, if you want to use the demo database, I put a link at the end. And you have to log in when you want to use it as your demonstration on your local machine. And you have to access the administrational area. So there is a button here which says migrate the data. What it will do is migrate the profile data, the user data, to graphs, and it also will read those items. Um, it will loop through all the values in that skill item, for example, and it will create a skill vertex type with this value, with this unique value. And even if another profile also holds a value like JavaScript or Java, the vertex will be created only once, because when it's already there, nothing will happen. It will just create vertices that are unique. Okay, how to do this? The migrate data button. I want to show you that. There is a setup page, and there is a button that says migrate data. And that button executes some code. It actually executes a method from a managed bean, which is called migration, and the method is called migrate data. And that method is returning a value of true or false, and if it's returning a true, then it will be display the success message. Otherwise, it will be display an error message, or an error page, not an error message. So very simple. So let's locate where this method is called, or where can it be found. Okay, it's of course defined in the faces config. You are familiar with that, and I want to show you how my Java works here. I have several classes that are there for the template itself, for the look and feel, for the UI, for the navigation entries on the upper right top, and so on. And I have a controller, and I have the graph related stuff. So the migration controller is what we are calling here with that bean, and it will create vertices of types user, or they are called person in this case, and it will create vertices of type skill. Of course, it will create other vertex types, but let's stick to those two. Before we have a look at the controller itself, what the method does, I want to show you how I modeled my metadata around the existing data. Let's start with the person. So as you can see, a person in my case contains a lot of methods. Actually, not really methods, because this is just an interface and not a class. But the key part of defining an interface class for using it as a GraphDB data source. This is what it is, a GraphDB data source. It is a data object. It is an element. It is a node. It is a vertex. So there are some specials about the definition of a vertex. First, you have to get familiar with annotations. And of course, you have to use and install the the OpenIDF Domino API. Of course, it is not a built-in function in Domino. After you installed it, you are able to code it in Domino Designer. So you should get familiar with the usage of annotations. Annotations are those guys without at sign in front, and they are standing alone, and they have no semicolon at the end. And they are defining some special elements and some special functionalities to your Java classes, or in this case, to your interface. In this case, we are creating vertices of type person, and this is why we call the type value person. You can call it whatever you want, but let me say that this value you are creating here is used as the value that is stored in the form field afterwards, because we are creating notes documents, and the value in the form field is one of the things where the lookups work with later. Okay, there are some There are some restrictions at the moment if you want to, or if you are using the latest version, the latest build version from OpenNTF, which is 2.00, then you may run into trouble when using a different name from other than from the class from that interface name. So if you want to call the interface person, then you may get in trouble when using a value user, because there's a bug which explicitly asks for the name of that interface that is used and not for the name that is used in the type value. So there's no problem with cases, but yeah, you got the idea. So the safest way is to set this value like you called your interface class. What I also like to do always is to add a new property to my interface, which is called $key. This is also a field that the graph implementation is using. It contains a unique key. It depends on how you create a vertex of this type. When you are creating a vertex, you have to define yeah, a unique key. Or if it's unique, it's your turn, but you have to define a key, which is a string. So this will be stored in that $key field in the resulting notes document. So if you are interested in how the key looks like, then you should create that method, that getter method that just returns the value of that field. And as I said, the add property annotation defines which fields are in that notes document you are creating. But always remember, you are not creating notes documents that are intended to be used by a user or by a notes database in a domino way directly. You are creating data that is entirely used for the GraphDB implementation. Okay, so of course you feel free to name your properties which will result in the fields whatever you want, but be careful with with the amount of fields. So there are different approaches. If you are creating data from the scratch, if you want to model some new data for a new database or a new application, and you say to yourself, okay, let's try the GraphDB way, then of course you have to model the properties, the getter and setter for each field you want to have in your documents. Okay. As you can see, I'm just using a subset of my fields that are in the profiles, in the user profiles that are already existing. So if I look at this user, there are a lot of more fields. There are some MIME types, of course, but there are phone numbers and hobbies and what the heck. But I'm just using a subset, which is the first name, the last name, the phone, and the email. So all the rest is not created in that vertex. I even could completely reduce the fields to just a single subset, which is the key in this case. So just a unique key, just to get the vertex unique and corresponding to an existing user profile. The most interesting part is the edges part. So if you want to be able to create edges from one object to another, you have to create methods in the vertex definition, which is this interface. So in this case, if I want to have my person vertex be able to embrace a new skill, then I have to create a method that contains the name add and remove. This is important. The values start with add and remove just to add and remove a skill. So in this case, you can see you have to parameterize, in this case, the skill object, which is also a vertex definition, just like this one. And the remove is also wanting a skill you want to remove from that person. So that for example, if you add a new skill, you have to create it before you can add it. If you are using an existing skill, then you can just reference it and add it with the same method. If you are removing a skill by naming or by parameterizing it, in this case, you are actually removing the edge, the relation between the person and the skill. You are not removing the skill itself. This is very important to know. Okay, so for the other methods, completely the same. So this is what the person does. And I show you the skill, which is even more simpler. The skill also comes with the form. I implemented the get key stuff. And the skill in this case just has a name. This is more than enough, a skill. Of course, you can add other properties which you want to use, but a name is the minimum I want to store here. And there's also a method here which is not named with add or remove as a prefix. It doesn't start with that add or remove stuff because we don't want to add or remove something. We want to get something. In this case, we want to get all the people that are associated that have relations to that skill. And this is what this method does. I come to that later, especially regarding that annotation, which looks very weird for the first time. Okay, back to the button and what the button does. There's a migration controller and the method is called migrate data. This is this one. So what we are doing here is looping through all the users that are in the database, already or existing user profiles, which is done by the search formula and the ODA way of looping through a document collection. This is what it looks like. And we call another method which is called migrate person, and we get the dog with, and here comes the magic. And the magic is we are instantiating a graph, great graph database. So I'll show you that, how this is done. This is very easy. In this case, in my configuration, there's the configuration document in the existing Notes application, but you also can hard-code it for the first test if you like. We have to define where the NSF file which will contain the graph data will be stored, which is the name of the NSF and which is and the file path and so on. And yeah, this is what this method does. It basically creates that element store and sets the name and the file path where the NSF file should be created if it isn't there already. Otherwise, then it's just used. And we set up the types of vertices we want to store in that element store. As I said, one good practice is to store or to use different element stores for each vertex type. In this case, we are using just one element store for all the vertex type, and we have 4 vertex types here. We have the person, which I already showed you, and we have the skill, which I already showed you. I didn't show you the birthday and the project, but this is exactly the same, and how they work is exactly the same. So it's not interesting. So we all add this to the configuration. We use the configuration to initialize the new graph. Here we are. And finally, we return the graph. We get the graph here through the factory, which is a dframe graph factory. Just copy and paste that stuff. You don't have to understand what's going on here. I don't understand what's going on here, to be honest, and but I really don't care about it. As long as it works, I don't care. So I'm also just a user. I'm not the developer. If you want to know how it works, just ask Nathan or maybe Paul. Paul with us is also into that. Okay, I'm returning that graph. Finally, it is just returning the graph. So we can't forget the helper stuff here. We got the graph. Bop, 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 bop. Here we are. So, and now this comes that we are creating a new vertex for an existing person. The person is the document, the existing one, and we create a new person. We are calling a method that is called add_vertex, which is creating the real vertex document, the notes document in the graph database, which is created automatically. And the unique key I'm using here is, in this case, the the unit of that person document. Why not? The second parameter says to the graph, okay, this will result in a vertex of type person. Okay. If we have the object, we can of course call the methods that are defined. That you defined prior in your, in this case, person class, of course. And finally, don't forget it. First error you will make is to forget to commit um, your data, your changes. I did, and I wondered why it didn't work. So always think about to and always remember to commit the commit method from the graph you're using. Okay, afterwards we are migrating the skills, which is doing nothing else than looping through all the values in the fields. If there are skills defined in that field of the person document, then it will do the same with with a skill. But finally, it will, and this is the key part, it will add the skill to the person. So this method comes with 3 parameters: the real person document, the old one, the graph element itself, because we don't want to initialize it here again, because we already have it. Just save some time. And the person object we already created in the step before. So what we are doing is create a skill, a vertex, and we add the vertex to the person vertex, which will create an edge. This is what the method addSkill is doing. We just looked at it. This is this one. Okay? And the same for the project and for the birthday and so on and so on. So it will result in something that looks like a Notes database. The database will be located, I can show you that. The database will be located in that folder because the profile database resides here in my case, and I just defined the name for the graph NSF. So if I click the button, I will do it now. It will do something and it will tell me, it worked. And now I return to my Notes client and I show you that folder again, that ODA folder, which now contains a new Notes database, which is called Profiles Graph. Okay, this is the way I computed the file name. Very simple. Just use the original one and edit _graph, and then we have it. And of course you can open it because it's a Notes database. But there is a problem with that database because it doesn't contain any view. I don't know how this is done, but it is not containing any view. So this is a database which was just created, but it has no view, so we are not able to open it. Of course, you can open it in Domino Designer and just save the untitled view, which is displaying all the documents. I created a template for myself, and which is more displaying more than just a simple all view on a simple default view. So I use this as a template, and I will replace that. There we are, and replace that. Blah blah. Yeah, let's do it. There's an error message, but it will work. So it will just add that view to that database, that view that I created and designed, where I at least can see what is being done. So if I look at the documents, I can see, yeah, this is a current time. So they were just created. You can see there are different types of documents here. The view is at least displaying those different types. We have edges and we have vertices. And you can see there are vertices of type, or let's say using the form person, and skill, and project, and birthday, and another person, and so there's no particular order in this case. So the order doesn't matter too. You can't open it because there's no form in that database, but we can have a look into that document, of course. There's the already named $key field, which is containing for a person is containing the unit of the original profile. Let's open a skill. You can see the key is completely different. It's not a unit, but it's the name of the skill in this case. The annotation type value, which I used for the skill, is written down in the form field, as I said. And there's one property also I defined for the skill Vertex, which is the name, the get name and the set name. You remember the methods I showed you? It's just setting the name. I will return, I will show you that, skill. This is the name of the form. This is the $ key field, which holds the key, which is just the name, and some redundancy here, okay. We could have dropped that here, but okay, just for demonstration. But there's a field created, in this case with the setter method, it was initially created called name. Here we are. So this is why we are getting that resulting document. The rest is completely graph related. And there's also, there are um, some values inside. Maybe you find values here. In this case, what you will find is the ODA graph type field, which contains a V or an E, which is just an edge, or in this case, a V is a vertex and an edge is an E. So if I open a skill, you can see the type is E, and we have a label, and we have an in, and we have an out, and there are IDs. So when it comes to edges, this is the interesting part. When it comes to edges, I don't know what this edge is for. I think it is for my own profile, as it might be the skills I have in my profile, because I can see there's a person and we have an amount of skills defined here, which is 9, and we have another 9 here. The order of these documents in that view is by their creation date. Okay, so I think they will correspond, and they actually do. So you can see from the properties of that document, you can see, okay, this is an edge. There's an in and there's an out, and there's a label. Let's stick to that label and the in and outs. This the person. We said we added a skill. This is what the migration data method did. It added a skill that was newly created, or it just referenced an existing one. It added a skill, and as you can see, when you are defining methods that add or remove edges, you are using a different annotation, which is the adjacency unique annotation. There are other ones, but in this case we are using this annotation. This annotation wants two properties, which is the label has skill and which has a direction. So you remember the arrows from the first chart, they point to a special direction. Of course, you can have a bidirectional arrow, a bidirectional relation, if it makes sense. But I show you a case where it doesn't make sense. Bob is working for IBM. This arrow points to that direction. Bob works for IBM. Some say to easily remind of how to define or to spell it is imagine your vertex as a substantive and the relation as a verb. Bob works for IBM. So this goes in that direction. IBM does not work for Bob. Somehow it might, but you know what I mean. IBM won't work for Bob. It's the other way around. So that relation is definitely only one direction, as it is for Jim also. So this is why you define your directions. What I don't understand yet, to be honest, is why I then have to create or I have to use the direction in way and not direction out, because from a standpoint, from a perspective of that person, that arrow points out away from me. So maybe that's some error in my own expectation. Or of course it is, or maybe it's just it's not just right. I don't know. But anyway, if you are aware of that, just remember to use the complete opposite. If you are not sure, you can of course use both. Direction both is also available. Should work also. More important is when it comes to defining the skills that one person have, or just to collect the persons that have that skill, this is a different type of perspective, then you have to remember that you use the completely opposite direction from the one you used here. See and notice the label I'm using here. Has skill for both, for removing and adding. Notice the label I'm using here. If I would use a different label in that case, it won't work. Okay? So the implementation is looking up the label, is looking up the direction if it makes sense, and this method will return what we call an iterable of type person. It will return a list of person objects with that skill. So this is why I call it the method get all the people with that skill. Get people with skill. Okay? So this is the way it works. A lot to talk, but of course you can check the in and out values here. You will see that the first part is a replica part, then comes the dash, and then comes the document ID part, which is definitely, you can see here is 5EC8. Do you want to bet that this UNID is 5EC8? It is, definitely. Okay, so this is also what, it's not interesting what is in that unit, but it's interesting what's in that key. So if I would change that key here a bit, that edge or these edges won't work anymore for that person. Okay, so it's the out. The out points to skills. So I think the 0769 is the key or the unit of that skill. 0769. 0769. As I said, this is a skill. I think it was CSS, yes. And it's using the unit in this case, and that points to that skill. So this describes that edge. Comes from the person, points to that skill. And the skill itself is being able to get all the persons back that are having this skill. How does it work? Very simple. Show you the code. No, just first show you the demo. Okay. I'm opening the profiles, but I'm not using the default one. I'm using the special one. This is a link to the graph-enabled profile. You can see there is that text is red labeled. The normal version is black labeled, and the graph version is red labeled. So in this case, we have exactly the same information on that page. But what you can see is that I can add a new skill here. What I'm able to do, I am able to, I don't know, not really, but I just added for demonstration. You can see the skill is added. I'm switching back to my database and I refresh the view. I hope you see the difference. Plop. The new skill is added. The new skill is here, and this is the new edge. This is the skill, which was which was PHP. And sorry again. And this has 6048, and this skill has skill edge points to 6048. The UNID in this case is the same as above because it's my profile. It's the same one. This is the ID of my profile. Okay, the principle is very simple. So the difference between the graph-enabled profile and the normal version is, of course, that the normal version doesn't have that field value in the skill field. Of course, we didn't change it. We added a new skill vertex. So even if I open another profile for that little guy, and I open the graph version and I add a new skill and I type PHP, it won't create a new skill. We won't see any new document down here. It is still the same, but we see the new edge. You see, the skill is the same, but the edge to the person is different. It's 5079. It's not my profile, so let's find Bart. I have no idea where Bart is in that profiles. No, I think could be the last one. Oh no, we are. I'm on the skills. I'm wrong. Sorry. Another person. No, I think this is Bart. C9. No, I missed him. Anyway, the profile, the skill was added as an edge to that profile, and therefore it is displayed. If I open up in the normal version, nothing to see because the field is empty, because it's just referencing one document. This is displaying edges. So how to display this skills in that graph-enabled person profile? Very easy. Remember that nice method that is called get people with skill. We have an X page profile graph, and somewhere there is a repeater for it. Where is it? Skills. It's a whole custom control. Okay. The repeater. The data source for the repeater is person get skills. I have to admit that this is a bit fake because we have a person controller. As also David Leedy is using always page controller. I'm doing that too. Person is a managed bean for that person page, so I have a person controller here, and the method is called get skills. What we are giving here is as a parameter is the unit of that person document, because this is the key to look up the person. This is what we do here in this method, profiles graph. We are all again getting the profiles graph and then call the get element method, which allows me to get a vertex based on an ID. In this case, it's the universal ID of the person document. We are getting a person class, and this is calling the old one, I think. Yeah, this is not using the new one. This is the old one. We are getting the skills from that person, not from the skill, of course. Yeah. Okay. So the person gets me all the skills the person has. So we have here get skills. Where are they? I can't see it. Person gets skills. Can't find it. Here it is. Get skills. It's an iterable. Here we are. Okay. So it's returning all the skills that are associated to that person. Bob. Okay, and we are building a list, and yeah, just a text list. Of course, we could return that iterable directly to that X page and then access the methods from the X pages level. But I tend to create some simple text lists because I then can manipulate the values before I hand it out to the X pages. Okay, this is one aspect. The second aspect, which is even cooler, is the search function. So if it comes to the problem, how to find people that have certain skills, then it may be cool not just to do a full text search, but to get all the people that are having a skill, and even if the skills are intersecting between the people. So if I check PHP, of course it's me and Bart. But if I check JavaScript, there is a third person and me again, because I'm also having that skill. PHP is only Bart, but JavaScript and PHP is this is a result of that intersecting list of skills in that case. So it's not an AND search, it's an OR search in this case. Okay? We want to look up both elements, and this is even simpler. So what this list is doing, it's just displaying all the skills that are in the database. But of course, we don't use the persons here because the persons are the results that we want to get. We want to get all the persons that has a certain skill, and then and there we use the get people by skill method. And the get people by skill method looks up for all the skills that are in that list. In this case, I'm looping through the list to get all the text values from the checkbox group, and I get all skill objects one after another, and then I call the method that I already showed you, get people with skills. So that this is also an iterable, and I just add the person, the iterable in that loop. I just add the person if it doesn't consist in my list of persons I want to return, so that we have a unique one. So if I, of course, I can uncheck that. And then the effect would be that I have double entries in that list, of course. If I search for JavaScript and for PHP, my name is 2 times in that list, and I want to avoid it. So I put that back in my code. So here we are. And again, JavaScript and PHP, and my name is already in that list, and therefore it is not added again. Okay? So this is how it works. So the bottom line is I didn't manipulate the original data. I created new data in a completely separated data store. The data is very, very small, or can be very small. The data is often referred as metadata because it's adding new values to your existing data. One may say you are creating redundancies when migrating the person profiles. Yes, you do. But it's best practice to do so, to create corresponding metadata information in your graph database, even for documents you already have. Always remember, you don't have to put so much effort in key value pairs in that metadata information if you don't want to use them directly. If you just want to reference the original data, in this case the original person profile document, then you always can do it because in this case, you have the key. Just look it up the traditional way. You can do that. Okay, I hope you got the idea, but I want to point out, I want to show you another demonstration I just uploaded. It was yesterday, May 1st. A simple little project which is called the Domino Explorer. I didn't find a better name for it. If you have one, feel free to contact me to contribute, of course. The project is on the OpenNTF stash, not the GitHub. This is the first one I did. I just exclusively uploaded to the OpenNTF stash. And this little guy does something similar, and I want to show you that just to get you an idea what it is doing. It is a tool to display all your informations about your environment regarding nodes databases, ACL entries with levels and so on, and users and groups in your Domino directory, and how they work together. Of course, you have to also run a setup which creates the metadata in that GraphDB. In this case, this is stored in the same NSF file as the XPages are in. But after you ran the scan of your system, you are able to access your databases, all your databases on your Nodes environment. Even you can also search it, and there you can see there's a profiles database. If you click on it, you get all the ACL entries. And I assure you, this is not done via the traditional methods by just scanning the ACL. It is accessing graph data that is holding those ACL entries for each database, because you may know local domain admins is an ACL entry you will find in almost every database on your system. Therefore, it would be nonsense to create a separate entry for that. It is just created once, and it is used several times by defining an edge to that database. Another example, if you want to find out in which groups a user is, just open the user, you can filter, and I then can show you in which groups, main groups, the bold ones, and other groups that are embracing those main groups, the user is in. So it's similar like to compute the effective access. And last but not least, I have an overview of all the groups. And if I want to access a special group like this one, I can see all the members, the user or server, or the group members that are in those groups. And I even can display empty groups. This may be important for administrators. And this is my or our development domino directory, and there are groups that that don't contain any members. So maybe we can get rid of them. Okay, so this is what this application is intended to do. It's version 1, it's not finished, but I invite you to contribute, to play around with it, and if you have questions, contact me. But the most important thing of this application is it uses GraphDB entirely. There is no other document data used except for reading. It's just graph data, nothing else. Nothing else in that database. It may result in a lot of documents, but it's entirely using the GraphDB API from the OpenNTF Domino API. It's a proof of concept. Okay, yeah, this is where my little show ends. I think I have talked too much, and I hope you got the idea, and maybe you can use it in your own application, and I'm pretty sure you find your own examples where and when to use it, and where this may come very, very handy in your own environment. So thanks a lot again, and yeah, hope to see you again soon, and have fun with GraphDBs. Bye bye.
And that's the demo. First of all, I really hope I pronounced Oliver's last name correctly. I certainly thank him for his time and look forward to him to return. And if you have any questions for me, here's my information. And I thank you for your attendance.